going to spend just a little bit of time today talking about zeros of functions, and then going to throw in this idea of multiplicity. And just to make multiplicity really, really simple, all it's saying is that if when we factor something, if we have a factor that occurs let's say more than once, then that's its multiplicity. So if we factor something out and we end up with a solution of x equals 1, but that factor shows up 3 times, well then we have 1 with a multiplicity of 3. All right, let's take a look, and I think it'll work itself out. So here's our question for today. It says find all zeros of f of x and state the multiplicity of each zero. So we're just going to work through 2 problems today. So our first function is this whole thing right here. I put it in different colors so we can see it. Now I'm hoping that maybe you can see this, that this is to the second power here, and the inside piece is to the second power. So if we square this whole thing, we're going to get a 4th power, aren't we? And then here we have a 2nd power here. So I'm thinking that we're going to have a total of 6 zeros. That's what I think. So this is what we're going to do here. First, start by factoring. So let's just factor this, and I'm going to take these things one piece at a time, if you don't mind. I'm just going to take this inside function right here, and I'm going to factor that, and I think it factors out to x minus 1 times x minus 1. And I'm just asking you, is x minus 1 times x minus 1 equal to x squared minus 2x plus 1? If you're not sure, pause the video for a second, do this FOIL work here, right? And see if it doesn't turn out to be this. And then remember, it was this whole thing here, right? Squared, right? So there's our squared, okay? I'd also like to remind you that exponents are distributive over multiplication. So really, I can put it in here, and I can put that in here, can I? So what I'm saying to you is that if I did that, what we'd have is this, right? We'd have squared here, right, and squared here, all right? I'm hoping you're still with me on what I just did, okay? I factored the inside piece and got these 2 inside pieces, and then I distributed this exponent of 2 across both those terms, okay? All right, so let's go to this next piece here, and let's just factor this out a little bit. And this factors to, let's see, x plus 3, right? X plus 3 times x minus 1. So how many, all right, so this is completely factored now, right? So how many factors, right, the way we'd get the solutions here to find the zeros is we'd say when is x minus 1 equal to 0, right? And that's when x equals 1, right? So we know that one of the solutions, one of the zeros, is x plus 1. How many of them do we have, though? We have 2 of them here. So we're going to take our multiplicity here. Multiplicity of, we have 2 of those factors here, 2 more of those factors here. That's 4 of them, isn't it? 1 more of those factors here. That's 5, right? 5. And again, if we went back and we solved, when does that thing equal 0? It's when x equals 1, right? When does this thing equal 0? When x equals 1, right? So the other one we have is this one. So we have to ask ourselves, when is x plus 3 equal to 0, right? And it's when x equals negative 3. So we have another solution, is x equals negative 3. Now, you don't really have to state this multiplicity of 1, but you can, that this has a multiplicity of 1, doesn't it? Okay, so these are our zeros. So we've accounted for all of our zeros. And if we check it out, there are 5 of them. There are 5 of them here, yeah? And 1 here. 5 plus 1 is 6, and that's what I thought we were going to get. All right, let's try this next problem. It's not especially difficult, but it's weird. It gives us a chance to use a different factoring technique. So, but our goal is the same thing, to find all zeros of this function. And in this case, I'm going to say that f of x is equal to x to the 6th plus 2x to the 4th plus x squared. And I'm hoping that what you're seeing is that they all have a common factor, and that common factor that they all have is at least x squared, right? You can get an x squared out of here, you can get an x squared out of this, and an x squared out of this. You're thinking, well, why don't you take out an x to the 4th? Well, you can't take an x to the 4th out of this, right? So you take the minimum, right? So what I did was I looked at these x variables, and I was like, what is the lowest exponential value they share? And the lowest one they share is 2, so we know we can take that out. So I'm going to take out an x squared, and then start factoring x squared times x to the 4th would give us our x to the 6th back, wouldn't it? X squared times 2x squared, right, would give us that, and x squared times 1, right? So I'm just saying this times this is that, this times this is that, isn't it? This times this is that. Is that okay? All right, so here are some factors that we have. My question to you is, can this inside piece factor out anymore? So now I'm going to look at this. And it does, doesn't it? It factors to x squared, yeah, sure, plus 1 times x squared plus 1. And in the weirdest way, if you don't mind, can we do this? This x squared up here. If you don't mind, can I just rewrite this x squared like this? X times x, because this is what we're talking about in the last problem. How many zeros will there be? And I'm saying that whatever the highest exponential value of a variable is, that's the number of zeros we should be looking for, isn't it? So we have, start making our zeros. Our zeros are, one is x, right? Because if x is 0, then 0 times 0 is 0, and no matter what this mess is 0. And how many of those do we have? We have 2. And x equals 0, multiplicity of 2. Should not use this m as your thing. I just ran out of space here, so please forgive me. I should have written the word multiplicity there. Right, we have 2 of these, so let's do this work. X plus 1 equals 0 when? Well, x squared equals negative 1. I'm just doing my algebra here. X equals the square root of negative 1. And what's the square root of negative 1? Remember, when we take a square root, it's going to be a plus or minus, isn't it? So x equals I, or x equal, let me do that. X equals opposite I, doesn't it? So x equals I. Look, we just did this one right here is this one, but what about this one? We'll get, right, we're going to get twice as many results because we have 2 of those. So we're going to have x equals I with a multiplicity of 2, and x equals negative or opposite I with a multiplicity of 2. Check me out here. 2 plus 2 plus 2 is 6, and I was looking for 6, okay? All right, I hope this is helpful. Don't get all hung up on the multiplicity thing. It's okay. I'm looking for your comments, and I hope this is helpful. You're doing great. Keep it up.